Always, always. So today, okay, not today. I don't know. Okay, anyway, I'm going to be explaining bubble sort. So the bubble sorting algorithm is an algorithm that allows you to sort an array in ascending order or descending order depending on what you choose. I'll show you how to change it in a moment. So let's just get a conceptual understanding of how the bubble sort algorithm works. So firstly, there's this there's this um loop which goes through and checks whether it looks at this index and compares it to the very next one and checks whether it's greater than or whether the next one is greater is less than it. My apologies. Oh, in the case that we're trying to get it in descending order, it checks whether it's less than that one. So is if 8 is less than 7, then it will replace 8 with 7. But it's not, so okay, we just move on. Then you see, is 12 less than 8? No, it's not. Then it goes over. Is 3 less than 12? Yes, it is. So then they get swapped, and then it points at 12. Now it says, is 2 less than 12? Yes, 2 is less than 12. So then we're just going to do that. And then it moves to the next one. Then is 8 less than 12? Yes, 8 is in fact less than 12. And then is 12 is 6 less than 12? Yes it is. So then they're gonna swap 6 12, right? And now it gets to the end. It says, is 14 less than 12? No, it's not. It doesn't swap, right? And then what happens on as you see, it doesn't go to the very end. It doesn't compare, because obviously if it gets here, there's nothing left to compare it to. So it only goes to, well, yeah, to the index, I guess, to the last index. Let's just say the last index is like I minus 1, right? Yeah. Yeah. So then what it does is it would then loop back, right? It loops back and then does the whole comparison thing again. Now 8 isn't less than 7, 3 is less than 8, so then it's going to say 3 8. And then here 2 is less than 8. My bad. 2 is less than 8, so then it swaps them. 8 is not less than 8, so it doesn't do anything. 6 is less than 8, so then it's going to say 6 8. 12 is not less than 8. But what's going to happen on this iteration is that it's not going to go to the next one. The reason is because this part is already considered sorted. Okay, this part is already considered sorted. I think that's why, right? That's that's my personal guess. Anyway, it just continues doing this, and then that is just like it'll goes. You saw on that one went until there. Then it'll go until there. Then on the next iteration, we'll only go as far as there, and obviously checking the next one still, but going only as far as there, then going only as far as there, and then going on as far as there. So you'll see what I mean by this when I implement the code itself. So if you see here, I've already begun writing, because this is my third time recording this video. Anyway, I need to go to sleep. Anyway, there's a mistake somewhere here. Let me just correct this. This should say size -1, right? Because as I said, it only in the beginning, not the beginning, but like it will only ever go to here, right? Okay, yeah, that's like essentially the reason why. Let me just adjust my pen. Then here it's going to say size -I-1. The reason we say size -I-1 is that's what allows us to get that effect of it stopping here, then it stops here, then it stops here, on each iteration, because this part is first, no, so sorry, nothing is considered sorted, then this one's considered sorted, then this one's considered sorted, then this one's considered sorted, then like that, then those, then those. Yeah, the reason is because it assumes that, like, you see how, let's say we had the 14 here, right? Let's say we had the 14 here, and I can't remember what was there, in 8, I think. So we have, oh goodness, bro. Okay, 14 and 8. Okay, so what it does is, no, I'm not gonna do the whole red thing. So it goes here, compares, then swaps away, goes there, compares, swaps, goes there, compares, doesn't swap, goes here, compares, swaps. Notice how the 14 goes towards the end. Checks, swaps, checks, swaps, checks, swaps, right? Or check, yeah. Notice how the 14 gets to the end, right? You see that? You see how the 14 gets to the end. And that thing happens on the next iteration. The next biggest number will end up here. Then the next biggest, and that's basically how bubble sort works. Then you say J plus plus. And then here, you're going to say if. Okay, so this is where the difference comes in, whether you want to go in ascending order or descending order. So in this case, we're going in ascending order. So we say if array, right, we've assumed that, so here we've declared it as array J is greater than, is greater than array J plus 1. This just means the same as saying array J plus 1 is less than array J, right? So that just means, is this index here, is the value of this index here greater than the value of this index? If so, then we're going to declare some int temp. Int temp is equal to array J. This is just a swapping algorithm, standard swapping algorithm. Then array J plus 1 is equal to, you know what I just realized? My handwriting might actually be terrible. It should just be equal to temp, semicolons, otherwise the code will not work. Obviously, we're not doing this on actual compiler, but yeah, and then there's that. Minus all this down here. Yes, so that is the algorithm. That is the bubble sort algorithm. You can test this yourself. Actually, maybe I'll include a link, but yeah, that's it. Maybe in the description. If I post this on YouTube, it's in the description.